Vision models, quirks, and fixes. Vision remains the messiest part of local LLM stacks, and this week's debugging threads show why. One user found image recognition working via Llama server but not through Open Web UI. The server logs never showed a base 64 image when using the Web UI, implying the client wasn't sending image content even though model Vision was enabled. Others confirmed it only worked when the image was sent without text, and that formats like WebP sometimes misbehave. The same setup worked fine via Jan.ai and Llama server's own UI, strengthening the case for an Open Web UI side issue rather than Llama.cpp or Llama swap. A separate point, tokenization by patches can misread isolated characters at patch boundaries, an R becoming an A when split, so don't confuse low-level vision artifacts with hallucination. In practice, a single tokenized image can cost roughly 1K context tokens. Most use cases don't need extreme context lengths to analyze a few images. If you don't see base 64 in your server logs, your client likely didn't send an image. Keep it simple. Verify the client sends images via chat completions path, and try PNG JPG first. If OCR is your end goal, use purpose-built pipelines. Allen AI's Olma OCR 27B25 is a 2.5 VL7B instruct derivative with extra GRPO RL for math, tables, and tricky layouts. It expects a rendered page, longest side 1288p, with metadata in the prompt, which their toolkit auto-generates. Reported scores on Olma OCR bench with the toolkit are strong across Arxiv, old scans, math, tables, and long, tiny text, with FP8 being the recommended variant for practical inference. The takeaway: end-to-end OCR quality depends as much on robust rendering, retries, and rotation handling as the base MLLM itself. Meanwhile, the community continues to squeeze vision models down to home lab sizes. A thread on quantizing Qwen3 VL30B, Thinking Obliterated, produced GGUF releases from Q4 to Q8, with an MXFP4 Q4 variant that trades a bit of speed for better quality than vanilla Q4 on non-Blackwell hardware. Users noted behavioral differences, e.g. NSFW refusals between thinking and non-thinking variants. Another reminder that training choices, not just quantization, shape outputs. Even at the extreme edge, there's experimentation. Someone asked about running a Llama on the Wisplay hat attached to a Raspberry Pi Zero 2W. Yes, it's tiny hardware, and no thread-long proof here, but it captures the broader trend. People push VL LLM workflows onto anything with a CPU and a battery. Expect strict trade-offs and aggressive quantization if you try. DIY acceleration docks and AutoRF. When your 2U chassis won't take a modern GPU, an OQ-Link dock can save the day. One builder moved from a P40 to an RTX 5080 via a Minisforum D1 OQ-Link enclosure powered externally, sidestepping 12-volt HPWR cabling on the server board. They dropped in a 4-port OC-Link card for future bifurcation and reported 140-plus tokens tests with Mistral, running on a Proxmox box with dual Xeon scalable CPUs and 512 GB RAM. Cooling/noise mods and reliable power delivery matter more than brand stickers. With external docks, you trade neatness for flexibility. If you're chasing throughput, don't forget the basics from the Vision thread logs. A single image costs about 1K tokens of context. 8K context suffices for most single image tasks. It's wasteful to run maximal context lengths by default when you're compute bound, especially on consumer GPUs. And for a reminder of the hacker DNA powering this ecosystem, someone built a radio transmitter driven by the mechanical flex of a piezo disc, ringing a crystal like a bell. It's barely practical RF, but it's a perfect metaphor. Extract signal wherever physics allows, then scale up. The same mindset fuels the OQ-Link dock, Pi-Hat experiments, and quantized VL stacks, bootstrapping capability with whatever's at hand. Training, routing, and specs. On agent performance, one project scaled a coding agent orchestrator to 32 times H100s and claimed a 160% relative improvement on Stanford's terminal bench, from 7% to 18.25% over the base Qwen3 14B. The orchestrator coordinates Explorer and Coder subagents as tool calls, trained with a dead simple reward, unit tests. Attempts at smart rewards reportedly caused policy collapse. The author is explicit about bias. The training environments are synthetic and similar to the benchmark, and about cost-benefit. In many cases, prompt engineering a SOTA model beats RL for the effort. Still, The jump puts a 14B orchestrator close to a 480B coder on that benchmark, 19.7%. It's a reminder, in agents, well-instrumented feedback tests beats cleverness more often than not. Agent infra is becoming its own product category. Bifrost advertises itself as a high-performance LLM gateway. 11 microseconds mean overhead at 5K RPS with plugins, adaptive routing across providers' keys, cluster mode resilience, OpenAI-compatible APIs, and Prometheus-level observability. The pitch targets multi-agent setups with many concurrent LLM calls and failure-prone toolchains. Community replies immediately benchmark the benchmarkers, contrasting claimed overheads with alternatives, which is exactly the mindset you want when your agents depend on the control plane. Finally, project definition remains the human bottleneck, even when the code writes itself. One builder of a generate full projects from specs. CLI realized teams often don't share a mental model of the deliverable. Their solution borrows Jeff Patton's user story mapping to visualize scope and dependencies before generation. Critics called it waterfall, but the point stands. Clarity first, code second. If agents are construction crews, you still need a blueprint both humans and machines can read the same way. Security. Link triggers MCP hygiene. A viral demonstration showed that a simple hyperlink on mobile can inject invisible prompts into ChatGPT via URL parameters and hidden markdown in user input, potentially triggering dangerous behaviors in the context of the user's connected tools, files, or memories. The critique: directly piping user-visible content into a deeply integrated assistant without robust isolation invites jailbreak-style abuse that enterprise customers won't tolerate. Risks cited include getting accounts flagged with hostile content, seeding persistent memory instructions, data exfiltration via code tools or even steganography, and general social engineering, all from a link click. The iOS app reportedly surfaces hidden content more visibly than mobile web, but the larger challenge is product philosophy. Consumer growth hacks, SEO-friendly query links collide with enterprise threat models. The defense playbook is maturing. OWASP published a practical guide for securely using third-party MCP servers 1.0, part of its GenAI security project with agentic security and the LLM Top 10. MCP here is Model Context Protocol, and OWASP's guidance is vendor-agnostic, controls for data boundaries, tool governance, secrets handling, and auditing across agent workflows. If your app chains tool calls and pulls in external MCP servers, assume prompt injection and tool misuse are normal operating conditions, not edge cases, and design the blast radius accordingly. Scale, trillion-parameter thinking, and trillion-dollar capex. Moonshot's Kimi K2 thinking landed with heavy claims and heavier weights, an open-source trillion-parameter reasoning model, natively INT4 thanks to quantization-aware training on MOE components, with reported 2x generation speedups under IN4 and state-of-the-art results on Humanity's Last Exam, 44.9% with tools, BrowseComp 60.2%, and STUI Bench Verified 71.3%. The tech blog emphasizes scaling both thinking tokens and tool calling steps, with examples of 200-300 tool calls for long horizon tasks. Community reactions range from admiration to a familiar slop taxonomy joke, and practical notes. The weights are roughly 600 plus GB. You'll still want serious VRAM and RAM to host, and yes, it's IN4 native, but you won't run this on a single small card. People also asked about how parallel test time compute factors into benchmark wins, reflecting a growing desire to separate architectural progress from inference time tricks. Use the official docs and repo. It's a significant release, but the usual trust and verify applies. At the same time, scale is about dollars as much as parameters. OpenAI is exploring U.S. federal loan guarantees to underwrite a potential trillion-dollar infrastructure build-out, positioning AI compute more like national energy or transport projects. The goal is lower borrowing costs and access to deeper credit markets, especially as the company pursues massive data center ventures and cloud deals. An IPO is not on the cards, according to the CFO. The focus is on financing the capex needed to keep pace. It's an unusual ask for a Silicon Valley firm, but the economics of frontier AI are looking less like software and more like utilities. Efficient training, pruning, and learning from errors. There's real progress in making models leaner and smarter without brute force scaling. One practitioner trained two 100 mem parameter LMs, Model A on 700 mem tokens and Model B on 500 mem tokens, selected via entropy-based filtering. Model B matched Model A using 30% less data by removing high-entropy junk, e.g. repetitive n-gram samples based on cross-perplexity and repetition thresholds. Reviewers suggested adding a random 70% control to confirm gains aren't from less versus enough data. The author cites related work and is building a reusable filtering pipeline. Data quality beats data volume when your marginal tokens add no signal. On the compression front, Cerebras released GLM 4.5 Air REAP 82B A12B. The full 106B MoE, pruned by 25% using REAP, router-weighted expert activation pruning, to 82B while keeping the router's control intact. No fine-tuning required post-prune, drop-in for VLLM, and near-identical performance on code, reasoning, and tool-calling benchmarks, with some cases even edging up. The insight: prune low-contribution experts based on gate activity and activation norms, preserve routing to avoid collapsing diverse expertise. One-shot pruning that actually generalizes to generative tasks is a big deal for deployability. A new ArcSieve paper proposes refine, retrieval-enhanced feedback via an in-context neural error book for multimodal LLMs. Instead of hoping a model remembers past mistakes, Refine retrieves targeted error feedback from a learned memory of errors, teacher-student setup, and injects it in context at inference to avoid repeating similar failures. It's a structured approach to learning from errors without retraining, especially useful for the messy failure modes of MLMs. Backfilling reasoning is another active area. One tinkerer fine-tuned a small model to synthesize reasoning traces for older non-reasoning datasets, aiming to augment conversational data that lost its thinking capability. It's not soda, but it's practical. Scaffolding datasets so larger models can learn explicit step-by-step reasoning during fine-tuning. And for perspective on multi-agent learning, Pluribus, Superhuman and 6-player no-limit Texas Hold'em, remains an important milestone. Unlike two-player zero-sum games with clean equilibrium properties, multiplayer poker complicates safe strategy and exploitation. Pluribus trained via self-play and beat elite pros across 10,000 hands without real-time opponent modeling during evaluation. It's a useful reminder that agentic performance at scale often grows from massive self-play plus careful constraints, not just bigger networks. Dev tooling, config and crypto utilities. Config is code now. Conform bills itself as pedantic for Go. Type-safe, declarative configuration via struct tags with built-in validation, hot reload, multi-source loading, YAML JSON-TOML custom, detailed error messages, and zero boilerplate. It leans on Go 1.21 plus generics for compile time safety and covers common validators out of the box. Roadmap items include secrets managers and distributed config. If you've hand-rolled config parsing and validation in Go, this aims to make that unnecessary. Also surfaced, Skull/E2ECP on GitHub, link included for those tracking new tools in the end-to-end security space.